Imagine this. You're a software developer. Shouldn't be too hard for many of you, right? So you're a software developer and you're working for this awesome project, and it's everything you ever wanted in a project. It has all the right technologies, it has cool people in it, you have a great team, you're achieving stuff, the atmosphere is cool. So it's the project you always wanted to be part of, and you're in it. So it's the start of a new day, and you just arrive at your workplace, put down your laptop, your favorite hot beverage over there, and you can smell it. It's just great. The temperature is right. It's not too hot. It's not too cold. The surroundings look nice. And you open up your laptop, start it up, immediately fires up. And you start your IDE, and slowly it starts dawning on you. What was I doing yesterday? And you remember, I was working on the functionality to order a board game, because the project is about creating an online store for board games. So there you go. You need a unit test for that. So let's create a unit test. A unit test to create an order for a board game. Simple, right? But in order to create an order, I first need a game object. So let's create one. Oh, I need an identifier. 42. Can't go wrong with that. Let's proceed. Oh, I also need a title. Well, test game, fine. Oh, a category. You know, test, right? Get on with it. Designer, John Doe. A publisher. Yeah, okay, Acme Publishing. Oh, come on. I'm creating a unit test for ordering something here, and I need to define the number of players? Really? Yeah, otherwise I don't have a valid game object, so I'll continue. 2 players minimum, 4 players maximum. I don't really care. encode. All I know is 13 numbers. I'll just smash in 13 numbers, right? And then the price, it's a big decimal. Okay, I'll just pick 1. I don't care about the price, right? And then, oh, come on, more fields. And there we are. You started out all energized about the new day to start, and within the span of 5 minutes, you're like, oh, come on. Will this day never end? And that's not good. My name is Jaap Coomans. I live in Tilburg in the Netherlands. That's just across the Belgian border from here. And I've been doing Java for quite a while. And currently I work as a software architect for Group 9. And I also am one of the founders of the Brabant Jug. And when I'm not working with IT, I'm also the father of 2 girls who brought me here today. And when I'm not spending time with them and IT, then I'm playing board games, or sometimes with them too. And yeah, I'd like to combine that with a nice craft beer as well. But that's more than enough about me. Back to our unit test. Have we created value here? I think not. We just smashed in some stuff to get where we wanted to be. But yeah, it adds no value to the project. And you might recognize this. See all these constants on your screen, having some rubbish data. At least I do. Takes me back to a project I was in a couple of years back. And it was a great project. And I was working there with a colleague of mine, let's call him Tom, and we were looking at our code, and we thought, hey, we can do better, right? This is not really adding value. And we started thinking, so what do we need? And we realized we need realistic data to get realistic results. So we started thinking, what makes data realistic? Well, first of all, it has to be representative. Representative for the data you really have going through your system in production. Imagine you have this line. It pops up when you run your test. It's pretty clear, right? It says illegal argument exception. Test is not a valid email address. Yeah, I can tell. But yeah, is it really helping you out finding the cause of this exception? What if it would have said this? Invalid email address Peter Johnson. That immediately rings a bell, right? You know that's a name, it's a full name of a person. So, first hunch, mix-up of fields somewhere, maybe? At least you know where to start looking right now. So representative test data, that gives you better feedback when you run your tests. It helps you understand the context of what's happening when your test fails. And at the same time, by thinking about what is representative test data, but also seeing it flow through your system, it helps understanding the domain of the system you're developing. And it helps you finding good constraints, like with the EN-code, right? If I really want to create a proper EN-code for my test, I have to think, well, what does that entail? It's not just 13 numbers, there's way more to that. And it puts me to thinking about, do I need a validator for that or not? Might be not really that important in my domain. So again, realistic data, realistic results. But if we have representative data, is that all? No. You also want to randomize your data. Because in your system, you won't have the same data go through your system over and over again, right? It's different data all the time. So you want that in your tests as well, in a controlled fashion, of course. And, well, you see randomized, but take note, randomized is not random. So random data, that's just a bunch of characters not meaning anything. But we also already established we want to have representative data. So randomized, different every time, but selected from a list or generated in an orderly fashion. The main benefit of having randomized test data is that it prevents you from test set blindness. Imagine again the class we had in the beginning with all the constants, probably copied over and over again from one class to another across the project. That's the default test set that will be here in the back of your mind. You're not aware of that, but it's there, and it's making you, it's controlling you. You make choices that are in line with that test set. Whereas if you have different test data every time, you're challenged. You're really challenged to think about, okay, what can happen here? What if some different value comes in here? And yeah, you might, of course, like Tom and I were, be tempted to use production data from your database. But yeah, that was just a very short amount of time that we really considered that. We all know GDPR and other security and privacy related stuff. That's a very bad idea. And even if you have data that's not privacy sensitive, then we're software developers, right? We're developing software. We're mostly creating software that didn't exist before, so probably the data didn't exist before either. So that's a bad idea. So if you want to generate it every time, then you're again forced to think about data formats. What if I want to generate a name? How long is that? What types of characters are in a name? Are there only Dutch names, French names, English names? They're different, right? There's also a couple of side effects here, and these should not be the drivers for choosing this approach, but they're pretty fun. First of all, it prevents collision. If you're having tests that are bigger than just a unit test, unit integration tests, component tests, mostly you have a little bit of state in your tests. And if you have the same data over and over again, you either run into collisions that are blowing up your test, which are the easy ones, or even worse, collisions that you didn't notice, where two tests use the same data without you knowing it. But if you generate different identifiers and different data every time, you will not have that problem. And even smaller nice side effect is that, well, if you randomize your test data, you might at some point generate a value that you didn't expect that blows up your system and uncovers a corner case that you didn't consider. Again, realistic data, realistic results. But we're here to talk about tools, right? It's tools in action. So yeah, you want to automate this. If you start Googling, you will probably run into this one, EasyRandom. And this one really does what it says on the tin. It's easy and it's random. It's about random data, so not randomized, actually proper random data, and I'll show you in a minute. And it's easy because I just need one line of code to populate my full domain object, no matter how complex it is. That's easy, right? It's an open source project, has some 1,300 stars on GitHub, which is okay, I guess. But it also says it's in maintenance mode on GitHub, so might not want to depend on that with your new software. But let's look at an example. What would it look like if you use this? Well, the first thing you do is you create a new EasyRandom object. And then the second line. In this example, I have my person class in my domain. And I can ask EasyRandom, okay, give me an instance of that class fully populated with random data. And then I can start reading that data from my domain object, like the first name, last name, email address, and street. But if I would run this, I can get this. Is that representative? No, it's not. So probably not the right use case. And there might be other use cases for EasyRandom, but this is not one of them. So let's proceed and find other tools. The second one is JavaFaker. That is, until recently, I thought it was JavaFaker. But the previous time I did this talk, someone from the audience was nice enough to tell me, hey, there's a new fork of JavaFaker, and it's called DataFaker. So I did a little bit of an investigation, and JavaFaker was slowly grinding to a halt. DataFaker is definitely not. It's alive and kicking, and it's the way forward. Right now, it's a drop-in replacement, so let's get ahead with DataFaker. It's, like JavaFaker was, a Java port of the Ruby Faker gem. Any Ruby developers here? Ooh, heard of the Faker gem? Have you heard of the Faker gem? No? Ah, okay. Too bad. But still, there's this whole other community out there in IT that's doing some stuff with randomizing test data, and then we're learning from them. I think that's cool. And yeah, so up until recently, I thought it would have 80 fakers, but with DataFaker forked at the beginning of this year, to be clear, it's now more than 200 fakers. And a faker can be anything from really high level, like, say, generating titles of a book, names of a person, addresses, car-related stuff. It's all in there. But there's also more low-level fakers that allow you to generate numbers or generate values based on a regex, which can also be really powerful. There's support for more than 60 locales right now, and it's also an open source project. You see the number of stars is really lower than EasyRandom, but remember this is since January this year, so it's going up pretty fast. Then what would that look like? Initially, it's more or less the same. You create a new Faker object, and that helps you to access the API. So if I want the first name, I use the name Faker to generate me a first name. Do the same for the last name. Then I use the internet Faker to generate an email address, and the address Faker to generate a street name. And if I would run this, I get this. See, Jules, that's a first name, a real one. I know a person named Jules, so that's realistic. Johnston, also pretty good, right? And yeah, well, don't go spamming, but I think that email address won't bounce. And well, yeah, Felicia Plaza. Can you imagine living there? I think it's near the beach with the palm trees, and everyone has a pool in their backyard. It's a really cool place. But there's more. There's also JFerry, and JFerry is slightly similar, but also slightly different. It's created by a company called devskiller.com, and they apparently created it for their own use and then open sourced it, which I think, again, is a really cool way to do open source. The main difference is that it's targeted at profiles, so coherent profiles of people. That's apparently the business they're in, so it makes sense that it's centered around that, and you'll see in the example what I mean with that. There's also some more basic tools, but it's way more limited than with DataFaker. And there's support for 9 locales, so if you're needing one of that, it's set up for you. Has a little bit more than 700 stars on GitHub, so it's a little bit in between the other two. But let's look at some code again. jFairy, starting to see a pattern here. You create a fairy object at first, and then the second line you do is you create a person. And this is not like we did with EasyRandom, but you create a jFairy person object. So this is not your own domain. You still have to read the values from there and then populate your own domain objects. But you can read all the values from there. So the first name, last name, email address, and via the address, the street. Now, if you run this, you might get this. Again, Alexandra. I know at least 2 people called that. Frost, also a realistic name. But look at the email address. It's coherent with the first name and the last name, right? So that's really powerful here. You don't have to keep that in line together yourself, like you would do with DataFaker. And then, yeah, well, summer place. Must be the same neighborhood, right? With the palm trees near the beach. That's really great. Yeah, so a little bit of a comparison, very quickly. So this is how these 4 tools, because JavaFaker and DataFaker are in here, went over time in GitHub stars, just to get a little bit of a indication of where it's going. You see JavaFaker really going up, and DataFaker coming up below, and the other 2 a little bit flattening out. But if you now shift the timelines, that's more interesting, right? You see that DataFaker is really targeting JavaFaker. So we know we want representative data. We know we want to have it generated. And we found a nice tool, or at least in my case, I opted for DataFaker. There's more tools out there, right? But yeah, if we just use that, we end up with more or less the same as we had before, but differently shaped. All constants in the header of a class with DataFaker in between will be not so useful. So can we structure that? Sure we can. So what I use for that, I call it test data factories. I know there are people that will call it an object model. Since there's no Wikipedia lemma for it, I created my own definition. So a test data factory is a simple static factory that provides generated, randomized, partial or complete domain objects for testing purposes. So these are factory classes with factory methods that create completely populated objects from your own domain model. Let's look at an example here. So back to our day at the office. We're back to our test. And after some work, I created some test data factories. And this is what I have right now. So you see, I'm creating an order. And in order to create an order, I need a customer ID and a game. So the first line says, well, customer test data factory, do me a customer ID. And game test data factory, give me a game. Notice the naming used in the methods. It's really expressive in the sense that it says, well, a game. I don't really care what game. I don't care about the title, number of players, price. I just care that it's a valid game object. And if you then use static imports, it becomes even more readable. So then you create the order, do some assertions, and in the assertions also notice that while the price is part of the assertions, I don't care what the price is. It can be €5, it can be $10. I don't really care. All I care about that the price of the game is the same as the price of the order that came out of it. And that really reduces complexity of setup that you need for your test data. So that was the simple case. You just need a game or a customer ID. Sometimes you need a little bit more steering. Like in this case, I want to test that only paid orders can be delivered. Or actually, I'm testing the opposite. I want to test that orders with any status that's different than paid cannot be delivered. And for that, I set up a parameterized test, and I want to have a game for every status. So I create another factory method, and it says an order, and you pass in a status. And that's all there is to it. So from the test perspective, this is really readable. I want an order with that status. The rest I don't really care about. So test data factories. They make you more productive. And at first that might seem a little bit counterintuitive, because you have to write all that code in your test data factory that creates objects, generates values, think about what kind of values you need there. But I've been doing this for quite a while now, applied it in several projects, and in my experience, over time, you get more productive. In the very beginning of your project, yes, sure, you need to set up quite a few new test data factories. But after that, you can reuse that over and over and over again. See, in this webshop example, it's about a webshop for board games. Imagine all kinds of tests in that system. Many of them will need a game, or a game with a certain property. So that's very easily reused then. And that allows me to focus on the test itself. Because if I can just type game is a game, I'm not distracted from my test at all. As opposed to what happened at the beginning of our day in the office today, right? We had to think about all kinds of data, didn't really think of real good values. Now I just have it at my fingertips. And yeah, personally, I also think it makes for more readable test, because a lot of your setup code goes in these test data factories. It doesn't clutter your test, makes them really readable. So another question I get when I introduce this topic often is, but we have these very complex objects. If I now create a test data factory for that, it means I have tons of methods in my test data factory for every single property in there. And also there's properties that are related. Well, valid point. So the next thing you can do there's actually two approaches. You can either return a builder instead of the object itself. If you already have a builder for the object, that's the easiest way to go. You just return the builder. But you can also create a dedicated builder so that you don't have a test data factory, but a test data builder. And that would look something like this. So, very simple example with returning a builder. I want an order builder, and I set the payment type and a payment date, build, and I'm done. So the builder just returns, an order builder returns a fully populated builder object, and I adjust two fields of that. But yeah, that can get out of hand. Because for this test, I need an order with more than one order line. And oh yeah, when something is paid, it also has a payment ID, a payment type, and a payment date. And for this test, that's really important to have, for it to be consistent. So then you can opt for the dedicated builder, like this. It would say, given an order with multiple order lines, taking care of the fact that there's more than one order line valid and all, but you don't care about the details, that has been paid. That sets all the other stuff. And you're gone. Again, very readable and hiding a lot of complexity. So to wrap up, good test data is representative for what goes on in your system. And test data should also be randomized, because you won't have the same data going through your system over and over again. That's also different every time. So your test data should be as well. There's some good tools to help you. I introduced 3 of them. I know from the feedback I get every time I do this talk, there's many more with many different approaches. They're all cool. So go Google. And yeah, you can use something like test data factories to provide structure to your test. But in the end, all that matters is realistic data, realistic results. Thank you.